All right. Good morning, everyone. It is 9:01 and it is Wednesday, August 13th. So we are welcoming in Todd Holt from Bentley. He is the Bentley guru, the subject matter expert, and FDOT alum. I always like to throw that in there because you're always going to be one of our own. Todd's going to be going over modeling end conditions today. And we're going to give everybody just a few minutes because there's supposed to be a few more coming on. But Mr. Todd, I'm going to let you run away with it, kind of give your overview of this interactive session, and
Okay.
then we'll just plow away from there. It is recording right now, so we'll be able to post this for whoever wasn't able to get on there.
Okay.
And I'm in the background if you need me, my friend.
All right. Sounds good. Thanks, Brian. All right. Well, good morning, everybody. This is going to be a pretty informal training question answer presentation examples of end conditions. So it's really going to be just kind of the fundamentals of end conditions. And what we would like to do or kind of see how it's run too, if you guys have questions, bring those in the chat or bring those up as we run through different exercises or different examples. Or if you have an example yourself you'd like to share, we can take a look at that if there's something that is not making sense to you in of end conditions. End conditions can do a lot of things. Help us search. So basically, it's from our hinge points out to the existing ground or help us target different elements. So we have our main components of the corridor, such as our pavements, our curbs, our sidewalks, buffer zones. But then from that hinge point out, we need to solve to existing ground or a certain condition. End conditions will do that for us. So we're going to learn about end conditions. We're going to go very basic, so apologize if it's not enough, but we can kind of see, we can kind of tailor it if there is other questions on there with that. So before we get started, I'm going to do probably about 30 to 40 minutes of presentation style where I just run through different examples. I'm going to bounce back and forth from ORD into that PowerPoint and go through different examples, kind of break everything down. If you guys have questions along the way, feel free to interrupt me. Put your hand up, throw it in the chat, say, hey, Todd, slow down. Could you repeat something? If you have something specific for a project that you're working on or trying to that, we can bring it up here. If we can't get the answer here, I'll do a little research. We do have a follow-up session, I believe, next Wednesday. Is it Wednesday or Thursday, Brian, the follow-up sessions?
I do believe it is on the calendar right now. And yes, it is Thursday, the 21st.
Thursday the 21st. So there's a 2-hour session after if there is something that didn't make sense during this time or a project specific question that you have. We have a 2-hour time frame where we'll begin in or on where you can come and ask for help as well. So this first part is kind of the knowledge transfer, but we can have different examples too. If you have questions in here, we can get to those after we get through some of the main stuff. But it's nice to keep it interactive. So if you do have questions, if something isn't making sense, let me know. We can look through it. You can share your screen. So Brian and the CAD office are on there as well. One thing, as you see my screen here for Teams, you probably don't see this because you are just attendees right now. But when we switch you from attendee to a presenter or an organizer, you're going to see a different screen to share. So we have the sharing option here. There's also the leave button. So if you want to leave, you can come back anytime you want. But next to the leave button, in between the sharing button, is an end event button. When we're sharing screens, or if you share your screen, pay attention to that. I've done it myself. That's going to close the event for everybody. So be careful when you share your screen not to hit that end event. If it does, I think we can jump back on a new meeting, or we'll get a new meeting on there. But be careful when you share your screen, not to scare you away from sharing, because we encourage you to share, ask questions, keep it interactive. We're going to keep it fun, and kind of just a lot of knowledge sharing, hopefully between it. But if we do share your screen, just pay attention to the icons and the buttons that we're picking on there. So I've done it myself. We can laugh at it if it does. So, but just be careful when we share your screen that it's going to change. That end event is there. We don't want to hit that button on that. Okay. So with that, any questions before we start on end conditions or anything else? We'll probably go for a little 90 minutes, and then we can take a break. If we don't get through everything, then we'll come back. But if you have questions along the way, let me know. As we work through those, I will be in FDOT's workspace. Some of the training examples that I sent to Brian is there'll be a PDF of the PowerPoint, so you can keep that as a resource for end conditions. Might not have all the information on there, but it is a good resource on there. And then we're going to run through a couple different examples in FDOT's workspace. But again, if you have questions along the way, feel free to interrupt me, put your hand up, throw something in the chat. We have a team that's monitoring that as well. So this is really for you to get the questions answered for your projects or just in general. So don't be shy to ask questions. All right. So with that, I'm going to just do our quick presentation on end conditions. This is going to be kind of the fundamental and the basics of end conditions. And then we'll actually get into the software and we'll lay out a couple of different end conditions. We'll dissect it, and then we'll build a couple of different ones. And we'll look to see what FDOT has in their workspace as well. All right, so what we're going to cover in the presentation is understanding end conditions. What are end conditions? How are those end conditions solved? The end condition trees or paths or branchings. So we can have a single point, say as our hinge point or an edge of sidewalk, and then from that we want it to solve to a different end condition or existing ground or right of way. We have different scenarios that we're going to build on there. We're going to talk about everything in end conditions and get that understanding there. So let me see if I can get a pointer on here. So, right, and when we're talking about our end condition trees, paths, and the branching, is we're talking about the branching from, say, this hinge point, because we might have different solutions that we want to have solve, and that's going to be the different branches. So we may have our cut 1 to 2, our cut 1 to 4, a fill berm, and a fill slope, or we might have a ditch that we have on there. So that's all the branching and the trees and the pathing. And then we're going to set priorities on the end conditions for what we want it to solve first, second, and third, and so on. And here's just a couple of different examples of different end conditions that we can use. And we'll go through a couple of different those end conditions, really get into the basics of using an end condition. And then we'll look at testing. We can use end conditions as a test. So if maybe we're a certain feature definition or terrain that we want, we have right of way that we need to tie into, we can build a search criteria within an end condition to help us search for right of way, and then we can find a solution for that. Here we have a couple different examples of that. Is of this one with the wall, is we have an end condition starting out from the hinge. It's going to go to the wall perch. Well, that's searching for an existing right-of-way or a condition that we need to draw a wall in. And then we can put another solution in there if it doesn't find that wall. So we're going to meet the criteria of our end conditions. And then we'll look at different constraints for end conditions and controls for end conditions that we'll have. So this is going to be all the basics of end conditions and kind of getting into some of the more complicated. So it's on there. So what are end conditions? Let me move that share button out of there. Move that out of the way. So in our engineering terms or the roadway terms, the end condition is our side slope or the slope treatment. So we have a branch that's coming out from our hinge point or part of our roadway. And we want to solve in different situations of different cut slopes or fill slopes. So we're going to have different multiple cut slopes that we're going to put in there. And I'm not going to read everything in this because you will have this PDF as well. But that's basically what our end condition is we're going to have different examples or slopes that we want to solve for in different conditions as we push that template down our corridor and down the alignment. And we're going to see, well, how it's going to solve for each of those points when it crosses, and we'll see what it actually does when it crosses those points, because we might have different situations or criteria that we want it to cross for, and it's either going to succeed or it's going to fail at that end condition. So it's either going to draw or not draw, or maybe move on to a different solution that we'll have. We're going to run through some of those simple scenarios to get that in there. So as a reference, you do have the PDF that you'll have here to fall back on. It goes through and explains end conditions a little bit more. I learn better when I do hands-on stuff, so we'll get to the hands-on stuff and kind of break everything down through that. So hopefully just bear with me as we kind of get through some of this stuff. But what are end conditions, right? End conditions are different than our normal components because end conditions allow us to search for during the component properties, we can search for or target different elements. Most of the time, we're going to target a terrain model, and it's going to be our active terrain model, so existing ground. And we can set a priority for that to search. So on our different end condition branch or the slopes, we can have it target a terrain model and solve dependent on our criteria. We can also look at different ways for target types. So there's different target types that we can use that we'll get into in the next slide. All right, so component properties, we're going to set that to look for a target type. We can set the different target types, then we'll set the priority on that. Within the point properties, we have in end conditions, we're going to have more end condition properties that we're going to look for. We're going to run through these in detail for check to intercept, place your point at intercept, our end condition is infinite, and the do not construct. And as we see here, it's going to have a definition for those properties. So when that's set, it's going to look for attempt to seek the target specified in the component. So if we check for intercept, it's going to draw this end condition based off the target type that we have in here. So if it finds it, it's going to check for that intercept. And then we can place a point at that intercept. We're going to go through these toggles and set those on or off. But on this is just, again, as information that will build on upon that. So we're going to just start simple and work our way on a little more complicated. All right, so more in the template components, so the end condition component. We talked about our target types. We have our terrain model. We can target to a certain elevation, horizontal geometry, linear, vertical. We can go to both. So maybe there's a ditch that we're trying to hit that we need to draw on. but we don't have a feature definition on it. We're just going to look for our horizontal geometry or vertical geometry and specify that to be within our search criteria for that target. We also have our feature definitions that we can target. So if we have a right-of-way line or existing right-of-way that we're trying to tie into, we can change that to horizontally, vertically, or both. So they're kind of like point controls, but it allows us to target different elements on there. So we can set that as this up to target a right-of-way line or maybe our terrain model. And then we'll go through and test and look at how that's going to solve within our end condition. So once we have our end condition set up, how do we know what it's going to do, or how do we know it's going to solve in the order that we want it to solve for? Right? Because we don't see in our main template dialog, all we see is our end conditions. And here we have multiple end conditions coming from our hinge. Down at the lower right-hand corner, as you guys know, there is a test button. That's where we're going to test our end conditions. And we can tell or test how it's going to seek those different targets that we're going to draw. So we can actually draw those different targets in there and help it search. We can test to make sure that the order of our operation, the priorities on our end conditions are met. We can look at our cut slope. So here's 6 to 1, 4 to 1, 3 to 1. We can draw existing ground and target that up and down and test that end condition to allow it to have us, see the sample of the target that is going to condition or test that condition that we'll see. All right, so that's kind of the end conditions. That's the start of it. We're going to jump more into some of that to really get to know the end conditions. So just bear with me as we get through some more of our slides, or kind of the boring part of the presentation. All right, so how are the end conditions solved? All right, so end conditions are going to start at a point. We're going to have it search for, so from that hinge point that we place it on, we're going to have it search with our criteria. The component is set to maybe a terrain. And then in the point properties of our second point, it's going to draw out from that connection point or that hinge point. And if those criteria are met in the point properties, it's going to start drawing out that end condition. All right, so it's going to start, can be any point that we put that end condition on. It's not at the end of another end condition. We can link end conditions together if we want to, but normally we'll draw one end condition, put the points in there, and solve it. There's no limit of start points for end conditions. So in the next slide here is, this could be an end condition that we would solve for. We could solve that. That makes sense because that's going to be kind of the out from our hinge point or the shoulder. We want to tie to existing and draw in a ditch. We might have an end condition that we put at the bottom of our ag base that's drawing down and drawing down and drawing down here. So this is just a different example that we put those end conditions at any point that we want to draw it out. And what we're having this do is look for the existing ground, and it's going to start drawing out that end condition because it's crossing that existing ground. And it's solving the condition that we put into the end condition. All right. We'll get back into our demo or into some different examples as well. All right. So continue on. So how those end conditions are solved, we first go to our point. The second the end conditions at that start points are solved, so it finds a solution. So it's going to move on to the next target, or the end condition solved by finding the intersection of the end condition with its target. So we're going to cross in that. And then we'll go through, throughout the end condition of that crossing point to the existing terrain, for example, or if it finds that target, it's going to solve depend on how we have those properties. And it's going to go through and draw each of those end conditions, draw that end condition out of how we're placing that. So it's first going to look at the first point or the hinge point, look to see what the target is. If the target exists, it's going to move on to the point properties, and depending on the point properties for check for intercept and place point intercept, it's going to start drawing out that end condition because everything is met on that particular end condition. All right, so here's an example of an end condition that's being met for existing ground. But we may have a second target that we want to draw, and a third target and a fourth target. So we can have multiple targets or conditions in our end condition. So it's going to first start here, existing ground. Criteria is being met, so we're going to draw to our first target. If we would get above that existing ground, it's going to search for maybe a lower target horizontal or a vertical target that we've met or designed in there. It would draw that ditch and then draw the other ditch. So we can have multiple targets in there. So it's going to solve by finding the intersection of the first target and the third target and fourth target. It's going to draw this end condition out to this criteria. So it's going to go over. Right. So when it's searching for those targets, and it's going to draw that using the sequential approach, starting for the first segment of the end condition and continue with each successful target find. It's going to keep drawing that out. Our one that we're going to do is just a simple ditch that's going to find the berm, but we can make it more complicated in that the different end conditions, because really, end conditions are going to be more just than a ditch or a slope. We want it to be, they can be pretty powerful and different ways to search for those. Right. So when that end condition is successful, it's going to start drawing out. So here's just different examples of end conditions. Right. So it's starting from our start point. We're finding existing ground. It's going to draw everything out and put a place point intercept or check for intercept, place point intercept on that different end conditions. So here's different examples that we may have. And we might have different branches as we move that in. So it's going to look for the criteria that we're putting into those different types of or that particular end condition. Right. So how are end conditions solved? Which start point is processed first? Usually it's from the hinge point, but it can be a random selection. So we're going to put it on that end point, or from the hinge out, it's going to build those out. So those are usually going to look at all the different, but the selection of the actual endpoint is random as it picks it. But the logic of thinking of it is going to go from the hinge point or the start point out and solve as it crosses that. So these are pulled from another PowerPoint. So hopefully that makes sense. But what start point is going to be processed first, it's going to hit that first point or look at that criteria. So it's going to look at the component criteria and then kind of draw that out. But we can test what those components are doing in our test window. Right. And that test window, again, allows for the comprehensive drawing our target. We can draw the target and place surface. Our line here is going to mimic that. We can see how it's going to solve for the different scenarios on there. So we can draw those targets. So let's see what else we got. Any questions so far from you guys on end conditions? Does everybody have the data set? Or I'm going to jump into Open Roads Designer. There was a data set. I don't know if Brian or the team, if that was sent out ahead of time to everybody, but I'm going to just jump into 2023. We can open up if you create a new work set or a new project, we're just going to get into our template library, and now we're going to build just a simple end condition and kind of walk our way through dissecting how that end condition is. Then we'll build some different end conditions in there. So then we'll jump back into our PowerPoint. In that, and let me share my other screen. And can everybody see my ORD screen? All right, so get that in there. So we talked about end conditions. So let's build an end condition, a simple end condition, and look at the different point properties and see how it interacts before we get that. So I'm in our the 2023 workspace of FDOT. I'm just in our practice file. It's just the normal training data set. So I'm going to go ahead and open that file. I'm going to open up our create template. And I did send Brian this ITL file that he can share with everybody. So if you guys do want that, reach out to Brian, or I don't know, Brian, if you have that sent to the group, if they have access to the chat or not.
It is in the chat, but I can send it out to everyone as well.
Okay. And yeah, so everything that I'm talking or going over today is in the chat. All you need to do is you can download from there. But if you need to have Brian send it to you, I think you have to put your email address in there. But what is in there?
I've got everybody on there. I can send an email right now.
Okay.
Yeah, I got them.
Okay.
Yeah.
Okay. Do that. So assuming everybody's familiar with the template library. So you have our end conditions here that FDOT has. So they have different examples. Within that folder or the ITL file that I sent to Brian, there's a completed templates end conditions. So there's different examples that we have in here that we're going to walk through. But what we're going to do is we're just going to create a new template. And this will be our template. This will be our demo. And this will just be a simple, let's do a fill. So we're going to do a demo for a simple fill slope. And we're going to start pretty simple, but we're going to dissect what that end condition is and the different priorities of that. So we're going to take a look at component properties and the point properties and really kind of get in there and dissect some of that. All right, so we have our new template that we created. So I'm going to come over to our main create dialog. I'm going to do a right click and we're going to create a end condition from scratch. We're going to do our add new component. So I did a hard right click, add new component. We're going to do end condition. This is going to be our, we'll just say fill slope. And this will be, let's just say 1 to 2. We're going to do a 1 to 2 slope. We're going to set our feature definition. So as we see here, when we create our new end condition, we're creating it, we're going to set the component properties. And this is our first look at the different component properties that we have. We're going to give it the name, our feature definition. So we'll go to our excess folder. And then we'll find in here, we're just going to do our think slopes. So we'll just do our slopes. And then here, so we're doing our fill slope. We've set our feature definition. This is where we set the different target types for the end condition. And we're just going to do a terrain model, have our active terrain. This is where we can also look at an elevation, our horizontal for linear, vertical, or both. So we have something that we want it to control by horizontally, vertically, or we want both horizontal, such as a ditch. We control those by linear geometry. We can also specify a certain feature definition that we have. So maybe it's right away or a wall or a match line or something else that we want that to, some condition that we want it to solve for. We're going to build in to that end condition to search for that particular target. Right. And then we'll do later on the feature definitions for right away. But for the first example, we're just going to set our terrain model. And then we're going to set the priority. We're just going to set that to 1. So when we have branching of end conditions, or we have different solutions for that end condition, we're going to set different priorities. So what do we want it to solve for first, second, and third, and so on? That's going to be with our priorities. And we'll go through setting these up. That's just a number of the order which we want it to solve first. It could be 1, it could be 10. I've seen, 1 through 9 as one set, and then, or 1 through 10 for one. Maybe it's 11 through 20, and then 21 through 30. So it's just a set or setting a priority of what we want to solve for first, second, and third. So when we have branches or multiple end conditions, we're going to tell it to solve for different areas for that. We're just going to leave this as 1. And then we're going to go to our dynamic settings. So I'm going to click on the little dynamic settings here, which is the little target. And I'm going to toggle off my apply affixes. Think about this a second real quick here. So I'm going to toggle off apply affixes because we're just building one side. I don't want the prefix or suffix that we have. But in addition to the dynamic settings, I'm going to go up to tools. And I'm going to go to under options or tools and options. And I'm going to load a preference that we have here. So I'm going to click on preferences. And I'm going to load this f.dot preference. So that will give us our step and the apply affixes. So I'm going to load that f.dot and then close. And then this apply affixes is working with this conjunction of apply affixes. So I'm going to turn that off because I really want it to set my X. I could set those here, but it's already predefined in there. So I'm going to click OK on that. And we'll notice that that's changing the properties in this dynamic settings. What we're going to use the dynamic settings for is to pick a point. So each point will already have a predetermined feature definition from our point list. It's at f.dot, we have very specific point names. We want to be able to use those different point names. So we're going to come in here and search on a particular point name that we're going to look up, and that is through there. We'll just set this to slope for now. And that's going to set the feature definition that's associated to that point name. So each component or point that we put to draw out this component is going to have this predefined for us. And then from the dynamic settings, I'm going to go ahead and use some of my precision inputs. So I'm going to set the precision to X and Y. And then I'm going to toggle in. I'm going to go 0, 0. So that's going to put my first point at 0, 0. and then I'm going to enter. And now that we're drawing our end condition, we're going to see in our point. So the dynamic settings knows right now that it is an end condition. And on the point properties, we have our different point properties. So we have our check for intercept, place point intercept, and then end condition is infinite, and we have the do not construct. So we have those extra properties that we can define in there or lay out in there as well. So we're just going to toggle on end condition is infinite. We'll come back to this do not construct. But we're going to draw it with the check for interception, toggled on, place point interception, and end condition is infinite for our next point. And then I'm going to go to my HS, which is a horizontal and slope. And this is going to be my slope. So I'm going to use that point name because we're still going to use the same feature definition. But I'm going to do an underscore, and this will be my slope. We'll say this is Phil. And I always ask, well, who's Phil? Phil's our slope. We're going to go 1 to 2. That's my dad humor. So if you guys don't talk to me, you're going to get all my dad jokes. And I've got a couple of them, and they are pretty bad. So we're going to get our point name. I've just modified that, so I'm still using the original slope, but I'm modifying it for the next point. And then I'm going to use the precision input of HS, and I want this to go, let's say 12, and then comma, and we want this, since it's Phil, we're going to go negative 50. And that's going to be a negative 50% slope. And then I'm going to hit enter. And then from here, we've just put our first end condition in there. So I'm going to go ahead and right click, and we're going to finish that end condition. And then here we're going to hit our fit view. Right? So we have our slope or our hinge point or end condition that's drawing. If we look at our component, I'm going to double click on there. There we see our component properties and our target. So our target type is the terrain model. We have the active terrain or existing terrain model in there. And we set that to a priority of 1. So that we're going to look at our point now. So if we double click on the point, there is our slope. We have our feature definition that was set from the dynamic settings. We're going to look at our properties. So we're going to check for intercept. We're going to place point intercept and end condition is infinite. We'll come back to this do not construct. So let's see what each of these does to this end condition. So we're going to leave everything on right now. And there's our constraint. So we constrained it horizontally from our slope point and with a slope of negative. So that put from the precision input, it put that horizontal and slope in there. Right? So we have everything set of end conditions. So where do we go to test end conditions for bonus points? See, who do we got in the chat? Say, Matthew, where do we go to test end conditions?
There on the bottom right.
Yes. Our test window. So we're going to go to that test window. Right, so we're going to go down here, as Matthew says. We got our test. Right, so that's going to bring up our test window. And here, test window, if we draw this and there, we're going to draw our available targets. So here we'll see our different available targets that we'll have that we can take a look at. And we're going to mimic drawing this active terrain or existing terrain. And we can set a different slope for that. So our end condition is looking for our terrain model or an active terrain. We can set the slope for it. We're just going to leave it at 0. We can put -2, -3, whatever slope that we want. And we're going to draw that end condition. And what we'll see here is this white line is the existing or the active terrain. So it's mimicking our terrain. So our start point for our end condition was up here. But if we cross our end condition, it's going to draw that end condition. And we'll see that it's checking for intercept with the existing ground and the end condition itself, and then it's placing a point at that end condition. And then our last, if we go outside or extents of that end condition, we drew that in at 12 feet and a negative 50% slope or negative 1 to 2 slope. We also toggled on that end condition is infinite. So if we get past that original end condition, it's going to keep searching out from that end condition to the existing ground. So that's really how the end conditions are working. But let's look to see at those other conditions. Right? So that's with everything toggled on. And we can reset and then we can close. So now we're going to come back to the point and we're going to toggle off end conditions infinite. We're going to toggle off the place. We can just toggle this off and that's going to check there. But what I like to do is I like to come in, I'm going to check everything off. So we're still going to search if the existing ground is met for the component, but then the properties, how do these different properties affect how this end condition is going to be drawn? We're going to take a look at that now. So if we go back to our test window, right, here's our end condition. We're going to draw in a slope. So let's just do negative, let's say 25. So I'm going to draw in a slope. All that's going to do is change that line, or I can do 25. And I'm going to draw that in there. All right. So now our component for that end condition is drawing, but it's only going to draw, or it'll draw whenever this target is found. So maybe we want to turn that off. So even if we're off of our target on that simple component that's just going a negative 1 to 2 slope and 12 feet out, the component itself is searching for the active terrain. So that component is going to always draw if that first condition is met, that it's searching for the terrain, even if we're off of the component itself. So it's component is looking for the terrain, it's going to draw. It's going to work the same way if a component is looking for that right away or another target. If it's the point properties are controlling how it interacts with that target along the component. So if we reset that and close, we're going to go back to our point and we're going to toggle on. We just want the check for intercept. Right? Normally we'll have the check for intercept and place point intercept, but we're just going to go through this check for intercept and we're going to click on that and apply and close. We'll go back to that test window. So now we're going to draw our terrain. We still have our component. We're going to draw that. But if we get outside of our start, but we'll see that it's starting as our component is checking for a point of intercept between the component and the existing. It's going to start drawing that end condition. But if we get outside and it doesn't, it's going to stop drawing that end condition. Right? So anywhere that it crosses that slope or that end condition within our 12 feet and our slope, it's going to draw. But if it doesn't cross or place a point of intercept, it's not going to draw that end condition. So that's why we use the other toggle on the point, is we're going to place a point at intercept or interception. So we want to check for interception, but it's going to draw if it crosses. We're going to place a point at that intersection or interception as well. And we'll click apply and test. And now if we draw our terrain, so we're going to cross And we'll notice that it's only drawing to the existing, and it's placing a point that it's going to draw outside of that. So anywhere along our end condition that we put in, it's going to draw as long as it will cross that. If it gets outside of that, it's not going to draw. Right, so this might be one condition that we want to draw, and then we can have a branch or another tree and another condition draw. So if it gets outside of that, we're not going to have it draw that end condition. The last one is if this was our final solution for 1 to 2, that's where we're going to do the end conditions infinite. So it's going to check for the interception point. It's going to place a point in the interception. Even if we go outside the extents of the component itself, which was 12 foot or the defaults of 12 foot and the negative 1 to 2 or negative 50% slope, it's going to always go and solve for that when we toggle this on. So if we come back here and test, now that we have all those in there, we're going to draw. So it's going to draw. Here's our end, is right at this line. So there's our end, but we're going outside the extents because we have the end conditions infinite, that this is our final solution that we want it to draw for within there. All right, so that's kind of the fundamentals of setting up those and making those points. Does that make sense? Anything not make sense in that initial setup for the end conditions?
I have a question for you, Todd.
Sure.
When you're setting up the end condition on the component properties, there is a checkbox for benching. What is benching?
So benching is, you don't really have it here in Florida because we don't have, everything's pretty flat. But if you had, say, a certain slope, for example, if we're coming up here, the benching, we can set that to, if I just draw something in here, let me do that benching. So if we want it to solve or draw like this slope, but then if our slope is 1 to 2 and we're getting above that slope, we need to put like a mow or flatten out that slope for a certain degree, or trying to think, let's do just a constraint component. So say our end condition that we're drawing in there, so we're going to draw an end condition. So we have a slope that's going to go up here, but then it's getting too high. That slope's getting too steep, so we need to flatten that out. So we're going to create a benching in that slope. And I don't want a closed shape. So we want to create something like this, that we can set that in the end condition, that we can build the end condition, and then we could just put that slope in here as we could flatten out that slope so it's not so tight or so high. It's a condition that we can build in there as we need, maybe after 12 feet in height or that difference, we need it to flatten out at a 12 foot, or we need a mowing strip in there.
So kind of like a maintenance berm then.
Or maintenance, yeah, it's a way to put a maintenance berm in there, basically.
Yeah.
And we can do that in, if I delete the components here, so if we would see if we can add a point. If we put in another end condition. If we had something like that, we'd want this, but we would kind of build that in, and then in this component itself here, we could add the benching, and then how many times do we want it to bench? in that criteria. We don't have it built in. We'd have to build in one, and then the maintenance berm, and then from there you could say, well, we want it to bench, 2 times up to that criteria. So it's going to run through and find that, and then it's going to repeat that and draw in that benching. And it's a way to put that maintenance berm within that component or build that in.
So pretty much, like, since we have just the 2 components here, it will essentially pick up from that right point and then draw that same 2 components again and repeat that. Is that that's what it's pretty much doing?
Yeah, that's what it's pretty much doing. It's going to find this and then draw it. We may have to have that just be one berm, and then we want it to bench twice in there.
Okay.
So if we test that, I don't think it's going to work. So we would have to come in. We wanted this. Go up. So if we go here, we want on this component itself. If we put, we'll see if I can get this right. So if I double click on that, I want benching, and we want it to bench 3 times. I want 3 counts of that benching. At this point, so it's going to check for it. So it's going to draw that end condition. So if we come here and test now, so there, and then it's going to repeat till it gets to that criteria. And there it's going to bench twice. So it's a way to get that build a maintenance berm into that.
Okay.
So,
yeah, like you said, never used it here, but I was always curious on what it did.
Yeah. So you can build you could build that in. So if you have different criteria, maybe if instead of benching you have a wall that you could put in there, so you just it's basically a way to do a repeatable end condition or that solution in there. So you want that to repeat on that slope. So, great question. Thanks.
Thank you.
Yep. All right. So what do we got next? So I'm going to go ahead and delete that component. So I'm just going to draw through, and we're going to new component. We're going to do an end condition. This will be our slope, fill slope. Do X, Y. So I'm going to go back to that original. We're just going to draw in our original fill slope. And I'm going to leave off. So again, the dynamic settings, that'll allow you to draw pretty quickly the slope and pick the different points that we have in here. So we're just going to do the slope. We're going to set this to, let's say, 12, comma negative 50. So that's going to be our 1 to 50. And then I'm going to right click and finish that in there. And then I'd want to come back on this point, and we'll just say that is our slope point on there, or the hinge point. So we're going to base everything off of this parent point. So now we're going to branch off or create a couple of different scenarios and look to see how those are going to test. So there we have a 1 to 2, and I'm going to clean up the name on this. So since those, as we put those in, those names were the identical names, it's going to increment that up just like everything else in the feature definitions that we put in there. So I'm going to clean that name up on there. So now we're going to do another end condition. So new component, We'll do an end condition. This will be our slope. And this will be our fill. We'll say that's 1 to 4. Oops. All right, we're going to do a mesh priority. We're going to leave that as 1, but this would probably be our second solution, or maybe this is our first solution in there. So we can set how we want it to solve in the order that we want it to solve for. So we're just going to leave that as 1 for now. All right, so I'm going to come up to the dynamic settings. The only thing I'm going to change in here is the slopes fill 1 to 4. And then I'm going to go to my slope and I'm going to merge these 2 points on there. So I'm going to go ahead and select on slope. I'm going to make sure it becomes white and I'm going to draw that in. And then I'm going to go to HS and this is going to be our 12 comma, and this is going to be negative 25. Put that slope in there. And then we'll right click and finish on that one. All right, so now we have our fill slopes are 1 to 4, 1 to 2, or we can put those different criterias in there. But now if we look at our point, we have the check for intercept, place point at intercept, but we're not going to do end condition. End condition is infinite because maybe that is our first solution that we want. So on that, we're going to have it just go to the extents of that and then move on to the next one. So if we test this, there we're also going to get a condition priority conflict. So what that is saying is on the component property, when we set that, our priorities numbering, both those components are set to 1. It doesn't know how to solve for that. That's where we can look at this warning. It's going to tell us that has end condition priority conflicts. We're going to use the check priorities button in our test window to view and fix that. So if we come up here and go check priorities, it's going to go from our pivot point, so that hinge point or the start point that all these are branching off of, and we're going to edit that. And there we'll see there's our slopes. And if we toggle here, there's our fill slope. So which one do we want to solve first? Right, in order, because right now if we do this, it's gonna try and draw both of those. So maybe that fill slope is 1, and we're gonna set this to, we can go 2, we can go even numbers. It's just the order of which we want it to solve for. Right, so maybe all our fill slopes are going to be odd numbers, 1, 3, 5, 7, 9. Our cut slopes are going to be even numbers, so 2, 4, 6, 8. Or we could go 1, 2, 3, 4, 5 on fill slopes, 6, 7, 8, 9, 10 on the fill slope. So those orders is just the priority that we want to solve. Look for first and then second. Now that we click OK, we don't have that conflict anymore. And if we test, so it's going to draw that 1 to 4 slope until it gets to the extents, and then it's going to move on to our second solution. So it's treeing off and having multiple solutions that we'll have, but then it's only going to go on if we had a 1 to 6 or another slope, or a 1 to 8 slope past that. So on one of these, or that last solution, is where you want to pick the end condition is infinite. So it's going to search for this. If it can't find it, it's going to move on to the next solution. If it couldn't find that, it's going to move on to the next, or this last solution is going to be our end condition is infinite. So on this point, for fill slope 1 to 2, if we toggle that on, we have the 2 conditions for the fills. So the fill slope 1 to 4, it's just going to go to the extents of 12 foot and negative 25, or the slope. And then if it can't get solve, it's going to move on to that next end condition, right? So we can build our cut slopes in that into those same preferences within there. That making sense? Any questions on that? Because I'll have you guys we'll do 2 cut slopes with that same process. If you want to, we're going to throw in there. So we'll have kind of an end condition with cut and fill in both solutions. But any questions on what we've gone over so far?
Hi, can you explain the even and odd numbers you were talking about again?
Yeah, so let's see. So when we draw or use the components, right? So our fill slope here is the priority of how we want it to solve. So either the numbering that we put in there is just the numbers of how we want it to solve in the priority that we wanted to solve for. So in this example of here, all my fill slopes, because I'm going to use just 1 through 10, or for the priorities. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Those are the numbers I want. On my fill slopes, I'm going to use the odd numbers. So the fill slope 1, that's going to be 1. That's going to be my first solution. If it can't find that, I'm going to move on to my fill slope 2, which is going to be my second solution, but I'm going to use a odd number of series to be the second solution in that list. So if I had another fill type solution, that would be 5, or I put that in the number. So it's the lower the number is the first solution. I'm just moving it to the next solution, and I'm just using odd numbers and even numbers to put in there. It could be 1, 2, 3, 4, 5. It could be or 10. It's just the number that you want it to solve for.
Okay, thank you.
It's just an arbitrary number that you put in there.
Okay, thank you.
And the other thing on that is a component that's going to solve, you're going to get the priority conflict if those 2 numbers are the same. That's why kind of odd numbers, even numbers, or 1 through 5 or 6 through 9. Hopefully that makes sense.
I think so.
Okay. So let's look at. So let's put a couple more in here, and we can kind of play around with some of those if it's not. So let's, in that demo or the simple fill slope that we're doing, let's go ahead and we're going to do a right click. We're going to put our cut slopes in there. So we're going to go back to end conditions. This is going to be our slopes, but this will be our cut. And we're going to go 1 to 4. It's going to be a terrain. We'll leave this. So we'll go back and set everything. Anything new, we're going to set that to 1. We already have the 1 here, or maybe on our cut slopes, we're going to set that to 2. I'm thinking I may have to change that. So we're going to do our slopes. This will be our point name. We're going to set that to cut. In the dynamic settings, so I'm going to use the same slope, same feature definition. We're just going to modify that to be a cut 1 to 4. Again, we're going to put our first slope in here. And then we want this to be 12, comma, and this is going to be 25, so positive. So this is going to be our slope cut 1 to 4. And then I'm going to enter and finish. We're going to do the same thing and put our fill slope, our cut 1 to 2. So we'll right click, add new component, end condition. It's going to be our 1 to 2. We'll set this to 5. We'll come back and go through that. Hopefully it'll make sense on there. So I'm going to, or this would be 4. that we're going to go. So all the cut slopes are going to be even numbers. All the fill slopes are going to be our odd numbers in this situation, or we'll go through and clarify that a little bit more on there. So we're setting up the component properties. And we're going to come back because we're branching off of the slope. And we'll use our dynamic settings this time. We're going to set end conditions infinite. And this is going to be our cut slope 1 to 2. And this will be 12, comma, and 50. So that's going to give us our 50% slope from our first point, or that green point, and hit enter. And then I'm going to right click and finish that. So now we have our fill slopes and the cut slopes. If we needed more, we could put those in there. So we have these on different priorities. So that's priority 4. This is priority 2. Our fill slopes are priority 1 and 3. So if we test that, we don't have anything that's conflicting. So if we draw, if we get below our existing ground, we're going to go to our fill. So it's going to go for this and then move on. That's infinite. If we get above, we're going to go and build those. So we could do 1, 2, 3, 4, 5, the different solutions. But it's just a way to order those and keep everything straight with the numbering of what solution we want it to solve for first, second, third, and fourth. So if we check priorities, we don't have any, but we can look at that. So if I look off of this end condition here in slope, I can edit that. So there it's going to look, since this is my lower number, there's my slopes fill, and there's my slope cut. There's my slope and slope. So I could come in here and say, we want our fill slope first, or the fill slopes to solve for first, or that. It's just lower number the priority that it's setting these to solve for in those different priorities.
When it comes to the priorities, like let's just say this in condition is on a template that we're kind of going back and forth between cut and fill for the like 1 to 4 slopes. Does it affect processing speed or power? Like let's just say if we did the priorities all as fills first and then go to cuts, is there any efficiencies when it comes to the priorities, or are those so minor that it really doesn't bother it?
It really doesn't bother it. It's just because it's looking at that existing ground, and it's going to transition. So it's pretty minor of how it's set to those. It's just going to be if it's above, we need to search for a cut. If it's going to below, it's going to go for on there. But no, okay. That's a good question. That would be probably more on maybe the length of your corridor and what feature definition that you have set on for the processing and your interval, the interval drop on it, the processing. But just the priorities themselves, as far as I know, they wouldn't have switching between a cut fill slope.
Okay, understood.
The other thing on that, though, it could be set on your terrain, because it's the existing ground. On this example, it's just looking at cut and fill. It's just looking for the existing, but it's going to go and try and triangulate and solve for that. So if your terrain model, if it is a big terrain model, you have extra, say, triangles outside of that terrain model, it's going to have to go run through and search that entire terrain model. So that's why we all also kind of tell users is maybe having a clipped terrain model. If you have a big terrain model, you're only searching for, or looking at a certain area. that's outside of your extents of your corridor. So maybe from center line, the corridor only goes, 100 feet out. You can do a clipped terrain and shrink that terrain model down. That would speed up your performance as well.
Thank you.
Yep. So does that make sense on the priorities? Is anything not making sense on the priorities there? As explaining that. Okay. Anything on component properties or the point properties that aren't making sense?
I have another question for you.
Absolutely.
As far as the finding in the terrain or targeting the terrains, let's just say in an instance that we have our serve RD file, but then we get another terrain file from say a permit job or something like that. Can we have an in condition target a certain terrain that is not activated when it runs through a corridor, but it's still finding the terrain? Or does it require to be activated in order to find it?
The first one, so with the settings that we have here, this is only going to be your active terrain model. But if you have, say, another terrain or another corridor that you want to target, that's where, close that and save this guy. That is where we can add target aliasing.
Okay.
On that corridor or on that template. So say we had a crossroad or a civil cell or something in here that we want this end condition to also search for, like State Road 97. We can do target aliasing, and that will show everything that's referenced in there. So it'll show the terrain surface. If you had another one, you would just come in here and pick that's for active surfaces or terrains or a different corridor. So I could have another surface in there that I could add this. So what this does, a target aliasing, it's going to find that terrain. And then in addition to that terrain, maybe we want it to search for another terrain model. We can add that in the target and build the list that it's always going to search for the active surface. But if we have another surface or another corridor, we can add that into here and click apply. So it's going to search for that and that existing and find that solution.
Okay.
That makes sense.
Yeah, so it's not within the template properties. It'd be this target aliasing that we would use.
It'd be the target aliasing that you use. Okay. Another thing that you could do on your project that we have training on is create a complex terrain model that would kind of build that in to the original terrain. So say we have an existing ground of our project. So on this one, say, we have our survey RD file of the existing, but there might be another part of that project or additional survey that's going to come in over here that we want to add into this. We wouldn't necessarily want to go through and create another terrain or add that, but what we can do is create a complex terrain model of the existing. So we can take this existing surface, and that's in a GDTM-RD. We want to create a copy of that, because if we're creating a complex terrain model, we need 2 terrain models to add in. But there's also the term of, say, a delta. If we create a delta terrain, which is an exact copy of our original, but we can have the original, we can have the delta terrain, and then we could create a complex terrain model of those 2. That would be, we'll just say Wakulla. And then in that complex terrain model, we can use the delta terrain to exchange out additional survey information. So if we had another terrain model that came in, we could edit the complex terrain model that's made up of our existing ground and a delta terrain. So those 2, or the existing ground and the delta terrain, make up our complex terrain model of Wakulla. Wakulla, we had additional survey come in over in this area. So we want to edit Wakulla, and we want to take out the delta terrain and add in the new additional survey. That way the name of the terrain model is staying the same, but we can exchange out information for that project. Instead of having, that would be another option that you could do. That makes sense?
Does for me. Thank you.
Okay. All right. So we got our cut slope. We have our fill slopes in there. Gone over priorities. So there we've just built a pretty simple cut slope. And that's kind of the basis of the end conditions in there. But what if we now want to make a fill slope end condition, but we have a fixed 10% slope shoulder that's going to tie into a ditch. That's going to be our second part. So we have a recovery zone that we want to build that's going to come out from our shoulder. We're going to build that into our end condition. We're going to go a certain berm, and then we have a ditch. We're going to build that out in there. Or if we have another condition here in our fill slope, and we want to build an end condition that has a safety berm out and then tie into a 1 to 6 slope. So we have our normal cut slopes and fill slopes here. We're going to do another end condition. Trying to run through the train. So we want to do a fill slope. We're going to do end condition. And this will be our, let's just say, safety berm. And we're going to set this to have this draw as a berm. So we'll have that as a berm. All right, so we want the train and active, everything that we're going to do right now is still going to be off of our active terrain model. And then we're going to bring back our dynamic settings, uncheck apply fixes. You come back and set my options, preferences. Since I got out, I'm going to have to reload those. Close. I don't want the affixes on there, but I do want to apply that. So this is going to be our new component. This will be our safety berm. We want to put in, this is going to be our berm. We're going to pick our slope. And then I'm going to toggle both these off. So we want the berm to draw. And we'll set this to HS. This is going to be 12-foot berm, do comma, negative 10% or negative 10. And we'll do enter. So there's our berm. And I should have put a point name. We'll come back and fix that. So I'm going to come back and fix. This will be our 6:1 cut. So our cut point that we're going to put in there. And then we'll set this back to HS. We'll go 10, comma, we'll go negative 50. So this should be my cut 1 to 2. Sorry. Or 2 to 1. And come back here and enter. So there is our last end condition that we're going to do. So right, on this end condition, it's still searching for the terrain. But on this point, we didn't toggle on the end condition property, so it's always going to draw those or that line in here, but this end condition isn't going to start drawing unless I toggle those on. Because right now, if we had that toggled on both those points, it's always going to draw the end condition. So I want it to check for the intercept and start drawing out this end condition from this point. So this is a way to draw those out. So I want to check for intercept, place point intercept, and then draw that berm and set those. So now if I test this, there I have a conflict. If I test this, so there it's always going to draw. But if I would get below those conflicts, so I need to come in and fix this. So maybe I don't want this 1 to 2, that 1 to 2 slope. I just want it to do this. If it can't solve for that, it's going to move on to there if it can't solve. So I want to set those priorities on there. And I need to fix the conflict. So I need to check priorities, check for my slope or the tree point that it's going to come out to. So there's my 1 to 4 berm. Here's my safety berm. So maybe my safety berm is 1. And then it's going to move on to my slope, fill, and then this is going to be 5. So I need to order those, or I could order that 1, 2, 3, 4, 5. So this numbering is just how I want it to solve first. Right. So if I want the berm, my safety berm to be the lowest number, I'm going to be that. That'll be 1. And then I can go in and set the other elements in there. And then if I click OK and close, so now if I draw this and test, it's always going to draw that one, because it's finding existing. Would need to have it set in there. So I need to go and check my other points in there, and then it's going to move on. So if I look at this guy, so I need to check for intercept, place point intercept on that endpoint. So this point is always going to draw, but it's not going to start drawing until it crosses this point, and then it's going to get out to there, and we have the lower numbers. So now if I test this, those are working, so it's going to come in. So there it's starting, there would be a conflict that I want. So maybe I don't want this slope if I want this solution. So I could get rid of one of these slopes, but then if it gets outside of that, it's going to build that in there. So as I draw this, it's going to go until it hits to this point. Or maybe I do want that as a solution. So there's another solution in there. But we'll know that it's not drawing this safety berm until it gets past this point. And then it's going to move on and draw that safety berm. So this way I can eliminate maybe this 1 to 4 slope, or I could change the slope to there. I don't need both these solutions in there if are on that. So that's a way to kind of order and build different solutions in there. Okay. Let's see. All right, so we've been going 90 minutes. I did promise a break, so let's go ahead and do a quick break. We'll do 15 minutes. We can grab coffee and do what we need to do. I'll set up a timer, but we'll come back in 15 and we'll build a multi-slope cut and slope with a ditch. So we'll add a ditch into that adjacent hinge. So we're going to build a ditch that we're going to add into our slope that we're going to work on as another example that we're going to build. So we'll do that after break. Come in, we'll go ahead and set a timer, and we'll see you guys in 15. All right, I'll give it another minute or so. And can everybody hear me okay? I am on a different headset.
Got you real good.
Okay, cool. All righty. Well, I think the next thing that I want to do is we're going to create a ditch slope. So we're going to create another template. We're going to add a ditch. And what I like to do when I'm building end conditions and even different components in the ITL file is I think of these just as Legos, as I will try and build as many components separately as I can. That way I have an example that I can use, and then I can piece them together and kind of build those as Legos as we kind of build those out. So the next thing that we're going to do is we're going to create our ditch to control that. So we also talked about in that PowerPoint different ways of controlling our end condition. And we can add parametric constraints, we can add point controls into those to force it to do or be a more dynamic end condition. So we can add those into. So even end conditions can read parametric labels, which are parametric constraints, or if we want to tie those into. We're going to build our ditch template to do that. So again, I'm going to go up to the root, and I'm going to do a right click and new. So we're going to create new template. And we're going to name this, will just be our cut, and we'll say a ditch, because everybody likes to build ditches. And there was an old joke that everybody wants their ditch to do something else, but we're going to show just the basics of building a ditch in there. So we might have different solutions or criteria that we need to build the ditch out. But hopefully, Brian said that I am an expert. I don't feel that I am an expert. I feel that I'm dangerous enough to know my way around in the software. So the nice thing about the software and even the engineering field is we're always learning. We're always developing new skills and different ways to create templates. And no template is going to be the same. You could have the same project on But you could have 5 different engineers or designers on it, and they're going to each come up with maybe a different concept based on things that they know and the comfort level that they have in their modeling techniques. There's not a right way or wrong way, as long as, in my opinion, as long as it gets that end solution. And really, that's what we're trying to find, is that end solution of it. So there might be different ways to do multiple template design or to design templates. There's not a right way or wrong way. There's just a way to do it. And if it works, great, you're going to learn something. Hopefully you learn something from each of these. But this is going to be our cut ditch, and we'll just do our interior for the name, or it could just be a cut ditch with a slope. All right, so we're just going to name that. We've created our new template. I'm going to come in and just double check my settings. So I'm going to go up to the tools and options. And we do have the prefixes or the preferences set. So I'm going to go ahead and load that. And then I'll close. I'm going to toggle off my apply fixes. That's going to set the stepping. So when we move and drag and drop into that, we can do those. And that's where I'm going to set the dynamic settings. Most of the time, we'll use the dynamic settings that we're going to draw this out. All right, so now that we have our new cut ditch interior, we'll come over here and right click. We can add new component. We're going to add an end condition. And this will be our name of this. This is going to be our, maybe it's the cut ditch, and this is going to be our interior, and maybe it's 1 to 2, whatever name that you put it, will make sense. It's going to make sense to you for your project. I'm just kind of running through some of the different training guides that we have and implementing them into FDOT's workspace. So we're going to create a new component. It's going to be our cut ditch. We're going to have it search for the terrain. So we're going to come back here. This is going to be our cross section. So our main component, we're going to draw this as a berm. Or maybe we have our ditch slope. So we want this to all be our ditch. Now, whatever feature definition that you pick, that's what this is going to draw. So we'll just go ahead and we'll just do this all as ditch slope. And we're going to set this to, the higher priority, we'll just set that to a higher priority of 8. That we can set that in there. All right, so we're going to come up to our point name. Come in here and set this. Again, we're going to try and find maybe a hinge or our slope point from the point name list that we have available. So I'm just going to pick slope for now, and we can always come back in there. But the main thing on this is it's setting, the point name is going to set the feature definition. So each component that we draw on the point is going to have these predefined names on them. Okay, so then we're going to come to our precision inputs. We'll go to X and Y, and we're going to do 0, 0, and then enter. And then in this, we're going to clear everything else out, and it's remembering the settings from the last time. So we want this part to always draw. So we're going to toggle off all of these, or we want this stitch to draw throughout. And we'll go through the different points, but we're going to leave all this off until the second last point and the last point that we place it on there. And remember, if we have all these point properties turned off, we're going to have it draw automatically for us. It'll always draw because it's finding that terrain. So we'll come back here. This is going to be maybe our ditch top. So we're going to find a ditch top for our ditch. Or maybe we have our berm top in. So we're going to do our berm top in that we can pick on that point. And then this is going to go for our berm top in. We're going to go back to the HS, the horizontal and slope. And we want this to draw for 8 feet. And we'll do a negative 10-degree slope. Because we have our horizontal and slopes, we're going to go 8 feet and a negative 10. And I'm going to hit enter. I'm just going to draw that. Right, so now we're going to go and draw our ditch bottom, or that back slope. So we're going to come and find a new point. So maybe in our list we have our ditch points that we can find. This always goes much. So maybe this is our ditch bottom end that we're going to use, right? And again, that's just going to set that feature definition. Right, we're going to use a precision input again as HS. We're going to have this be 6, and then we'll do comma, and this time we want this to be a 1 to 3 slope. So we're going to go 1 and then semicolon 3. So we're going to go 1 foot over, 3 foot down. That's going to be our ditch bottom in. And this here, we want it to go down, so we need a negative 1 to 3. We could fix that if we needed to, but we're going to go 6 and then comma negative 1 to 3. We'll hit enter. And then we need our ditch bottom. So we're going to switch the point name here from ditch bottom in. We'll do this, our ditch bottom out. We're going to go HS. Again, for presented input, this will be our 4-foot ditch bottom at a 0% slope. And we can hit enter on that. And then we're going to come back up to our points. And maybe we want another. We want our berm top. So I'm going to go back and try it. Maybe this is the top of our berm. So following that naming convention here, we're going to go berm and then top will go out from the point list. So there's our berm top out. This is going to be our HS, and this is where we're going to go 6 for a distance, and this is going to be our 1 and then semicolon 3. So we want 1 to 3 up. And we'll hit enter. And then from this point, we do want it to start solving. So we're going to check for intercept. We're going to place the point at intercept, and our end condition is infinite. So if I zoom in to my window here, all right, so from this point, we're going to have it be, this is going to be our 1 to 2 slope. So we can set this to our cut. Look for the name. So 2 to 1. We'll just set that to, there's 1 to 1. Maybe the 1 to 2 back slope, or whatever name that we're going to pick in there. So maybe this is our 1 to 2 back slope. And we're going to set this, we want it to go 3 feet at 50%. So we're going to put 3 comma 50. Right click, and then we're going to end and finish our ditch. And we can fit view on that. So there we have our ditch. That's going to draw, but it's not going to start drawing until the existing ground hits this point and goes above, because this is the end condition that's drawing. So in the criteria that we're building into this is it's not going to draw this ditch until it hits to this point when that existing ground covers it. And then from here, it's going to go and find the end condition. So this last segment is really controlling this ditch. So let's test that out to see what it's doing. So if we test this, we can draw this out. Right. So here's our point. So if we don't cross that point, we can go up to that point. It's not going to draw. It's only going to start drawing once we place the point intercept after that point and out to that end condition. So it's going to solve for that and draw. So this point is really controlling how we want that ditch to draw. So it's going to come back and we need a ditch if it's going to find that existing point, and then it'll go up and solve for that. So from that point out, it's going to go and solve infinitely away from that. Okay. Does that make sense to everybody? Why that's working that particular way of how we set that up?
So, quick question: when it comes to, ultimately this entire component is an in condition being set up. Let's just say that we have a template that we know it's going to have a ditch for a good length or a good length that it would be in being drawn in. If we wanted to do an in condition tree for different tie downs, ultimately is it better to draw in the ditch area as a normal component, not as an in condition, and then just do in condition at the tail end? Or would it, ultimately I wouldn't want to draw the ditch 4 different times for different conditions.
There's probably multiple ways to do that, but if it's going to be, because you're going to have different solutions, and you would build that in off of that tree, and we're going to add this in, so this is just one solution that we would have. But if it meets that criteria, and we might think, on those other slopes, is this point where it's drawing the ditch, what is that? What's the restriction for the ditch that's going to tie, or what are the restrictions for those other conditions? And we can build that into to that. We could also, on this point, add in the labels. So if we wanted that to vary, we could add that in there. I guess I would, with this way, the software is solving that to tie into, but if you had ditch where you knew that you were going to have that ditch, you could draw it as a regular component within there, or you could build in your criteria for your other slopes. And we're going to add this ditch into our demo fill slope that we put into, so it has in there. It's also up in this one, so there's not a right way or a wrong way. It's just the criteria of what that ditch is going to be. I don't know if that answers or helps or not, or the criteria on that.
I know there's always different ways to skin a cat, as they say. So
yeah. But I guess in my opinion, it's, if you can build in that end condition or the different conditions that you want to solve for, or maybe it is, if maybe this is your first solution of when you're prioritizing that tree, is I want it to first do my ditch if I know that I'm on that, and then I can work on to the second solutions. So maybe as the first solution or the priority, the ditch is the lowest priority, because I know I'm going to have that. If it can't solve for that ditch, then it's going to move on to the different. So to me, it might be within, if we come here, all right, this cut and fill in this example, this is what we're building. We're going to throw it in here. Is maybe this ditch is my lowest priority, because I know I'm going to have that be, I want this to solve first. And if it can't solve for that, I'm going to move on to my other situations or other solutions. So it would be that would be how I would kind of tackle it. I would think I'd have to kind of see, in that particular situation, there's not a right or wrong answer. It's just getting it to do what you want it to do in there. But that's, my knowledge is I would try to just get, that lower, have the priorities solve for what I want to do it. The other part of it is that you could have just one template that just has that ditch on it. But we also kind of wanted to make it dynamic, is where we want it to solve, have the different solutions in there, so we don't have to have multiple template drops or different templates, that we can just use one, and that's going to find that solution for everything. So I don't know if that helps or that answers that, Matt.
Yeah, thank you.
Sure. All right, so go back. To our ditch. So I'm going to go back up to that. All right, so now that we have this, we can do just that, is we can come in and we can build our Legos, or build our template, or build this end condition. So maybe we want our different end conditions, and then this ditch to add into that. All right, so we have our demo for a simple slope. I'm just going to right click on this and copy. And then I'll come up and I'm going to copy this, and then I'm going to come in, paste that demo slope, and then I'm going to make that my active, and we can rename this. So maybe this is our demo simple slope, but we want with the ditch now. All right, so we have that solution in there. All right, and maybe we don't need, this other solutions on here, is we don't want that. We just want, maybe it's 2 cuts. The cut 1 to 2, cut 1 to 4, and then our final fill slope, or the different slope that we have in here. We can do a single click on that cut ditch interior, and then we can drag that in and drag and drop onto the slope. Now we just have another end condition into this. So we added that ditch into here. Maybe we don't need this slope or whatever slope or conditions that we want to have into here. We can get rid of one of these other slopes. So we don't need the safety berm if we have the ditch, or maybe we need the safety berm. That's going to replace that ditch. Whatever criteria that we can build in there, and then we can test to see what it's going to do. All right, so if we draw that, it's not getting to those other solutions. So maybe we don't need one of these other solutions in there if we're putting that ditch in there, or test. But that's the other thing about this, is we can test it out to see if it's going to make sense before we actually take it to that the template. So on this one, I'm going to go and right click and delete components. So I'm just going to delete those, and I'm going to do Control Z. So I'm going to delete that component, and then I'm going to delete the safety slope. So there we have, or maybe we need that safety slope in there. We can tell it what to do by the priorities, how we want to test those out. So now if we test this, we can draw, those are solutions. We just need to look at this priority here, is, maybe the ditch is our first solution. So we can test and check priorities. We don't have a conflict, but we want to check on there. So there's our ditch. Maybe that's our first solution. And then if I can't do the ditch, to where that's one, Maybe this is this is 9, or these are odd or even, whatever number that is. Lower number is the priority that we want to solve for. So maybe this is 5 and this is 3. Right. So as we test that, it's just going to go in the numbers where that could be 1, 2, and 3, 4. So we want the ditch to be the lowest. Then if it can't solve for that, it's going to go up, or we don't want that end condition in there. Or depending on how we have these built, we can close that and then test. Right. So there's never getting to those other solutions of this. So maybe we just want that end condition not to be infinite, but only go a certain, and then move on to that other end condition on there. So if I can't find the ditch in our cuts or those fills, we want it to move on. So we take off that end condition as infinite on this point. So now when I do that, it's going to draw this component. It's still going to check for intercept from this point out, but it's only going to go what this distance is. So maybe that's 3 foot. Then it's going to move on to our cut slopes. So for our cut solutions, we want the last one. So if we toggle off that end condition is infinite, it'll move on to those next solutions that we're trying to solve for. Maybe that's our lowest condition. We apply, and then we move on to our point. Then we want it to go to the 1 to 4. Or if we want it to, if I can't find the 1 to 4, that's our final solution. If it can't sign there, if it's in the fill, it's going to go back and do that. So here, if we draw, it's going to do the fill. If it's above that fill, the point, that's when our ditch solution needs to draw in. Once it gets past that criteria, it's going to move on to the next slope. And then if it's past that, then it's going to infinite in there. So that kind of comes back to your question, Matt, or Matthew, that's how I would kind of prioritize that. Is this would be our first solution, and then slopes to kind of build that out. And then if we wanted to control our berm, the top end, all right, we can look at the points. So here, it's always going to draw to the constraints. So this from the slope to the berm top end is always going to be 8 feet and a negative 10% slope. If we want it to be dynamic, we can control the slope by adding in a parametric label or a horizontal feature constraint. Right, so we have those. But if we do a label, that's going to be our parametric constraints. So maybe this, we want our, we can name this to berm slope, or we want the berm slope. And then what this allows us to do is we can apply this parametric constraint as a label and make that adjustment from 10% to 11% or 9% or 8%. This allows us to have this be a dynamic way to control this value for this slope constraint. Likewise, if we wanted a berm width for the horizontal, it's not always going to be 8 foot, or maybe it's 6, or maybe it's going to transition. This could be a parametric label that we put in for berm width. So that's going to make it this dynamic that it's not always going to be 8 foot. We can have that go from 8 foot to 10 foot by adding these parametric constraints in with using labels. We could also target a horizontal feature. Right, so this is just doing it horizontally. So we could use this, or if we wanted to search for a certain feature definition. For berm width, it's always going to draw it out 8 feet, but then we can add in, let's say, 20 feet. We're going to build an envelope or a range for that to look at and search for a certain feature definition. So maybe we have our roadway design, the plan profile, 2D lines, and we have, a slope or a slope break that we're going to use. So we could use this as well and draw in our feature definitions and then add those as horizontal features to that corridor. So it's going to go out and find that and always draw out 8 feet. But in addition to, we want it to search out another 20 feet for a total of 28 to find that slope break line. So we'd add horizontal feature constraints. If we just do labels, we don't have to add the horizontal feature to that corridor. Adding horizontal features, it can increase the processing time, because think about how that's going to work is it has to go and search for that horizontal feature each time and make sure that it's in that particular, the file or associated to it. So there's different options of how to put those in there. But this is another option that you could do. I would probably do the labels myself for parametric constraints. Just learning those, it's that I can put those in and put them into a certain station range. But this is all ways to make these a dynamic template other than the static in the values in there. We can add those two different in there. So we'd add parametric labels. We could also add a horizontal feature to control the horizontal constraint if we needed to. Right, so once we have those labels in, click apply, we can move on to our next point here. And here we have another slope. So maybe that label, we want that to be a berm top in, or dependent, this is our ditch bottom. We now can pick the berm slopes, but maybe that's a different label than this berm, right? So if we would apply this berm slope, it's going to change both of these. So maybe this one, we need a different name. And so this is our berm slope and ditch bottom. So how we want to control it, we want to put those unique names in or build those into the label. So that's maybe our berm slope ditch, or the ditch slope or slope to control the ditch, or this point. Right? And then the ditch bottom, so we don't have anything on this point. We just have the slope. So we want a way to control the slope of our ditches from the top berm down here, to change it from -33 or the 1 to 6 or 1 to 3 to a different slope, 25 or 50%. We can change that slope by applying that parametric constraint and parametric label to it. Apply, and then if we want to do our horizontal, so we want to be able to control our ditch bottom width from 4 feet, maybe it goes to 2 feet or 3 feet. Right, we can do a ditch bottom width label and add that into there. So now we're building in to this template or into this component different ways to control it. We can just apply a parametric constraint to that using this parametric label, that we can vary this default from 4 foot to 2 foot to 6 foot, or we come in there. So this label is controlling this as we apply it as a parametric constraint. And it's going to override this default value that we put in here. Right, so we can do that throughout and build those into that berm, the top. So if we had one that we want to pick, or we have it in the list, or we define the new one. And we'll see as each time we put these in, we can pick on those different points to put those in there. Right, so we did our simple ditch. We added that in. We set the priorities. We look to see different ways that we can control our ditches as we put them in. So parametric labels or horizontal feature constraints. So this is a dynamic end condition that we can put into our different areas there. All right, so there we've looked at our component properties. We still have one more where we're going to target a right-of-way line. So we're going to build that, and not in the next exercise, but we'll get to that. So the next one that we're going to do is we're going to build a constant width, but a varying slope clear zone. So maybe we know what the width is from our tie-in point, but we want to have a variable slope that we're going to build in. So we're going to take a look at the do not construct point property as we draw this. This one gets a little confusing as we work through it. But basically we're going to come in, and if I look at my template endpoints here, is we have a clear zone coming from the hinge, and we're going to build a do not construct point out and an end condition. That's going to be 18 feet out that we know, but it's going to have a variable slope. And that's going to draw. So we're going to build this end condition. And the only thing difference on these is on this end condition here is we're using a end condition to search, but we have the main components of it set to a do not construct element. And what that is doing is we have a known distance from our hinge point of, say, 18 feet, and we want a variable sloped that's going to go 3 feet above or 3 feet below that. So we have a variable slope. So it's going to come out, find the terrain at 18 feet out, and then we can tie it in above or below 3 feet. So if I test this, there's our components, right? So we have our two slopes. We have our terrain that it's going to hit. So it's 18 feet out. But there we can have a variable slope to the top once it gets past it. We're going to have a variable slope to the bottom, and it's going to get past that information on there. So that's basically what we're going to draw in, is we have a restriction or a clear zone for grading a right-of-way where a horizontal position of our tie-in is known, so 18 feet, but we want to have it develop a variable slope, either 3 feet above or 3 feet below that. So this is our final solution that we're going to build in. All right, we're not doing end condition infinite because we don't want it to go outside of that criteria. We're going to build this template. So I'll go ahead and close that. So we'll go up and we're going to create a new template. Create new template. And this will be our clear zone example. Right. We're still going to use our dynamic settings. We're going to create a new component. We're going to go end condition. This will be our clear, and this will be zone. And this will be our cut. All right, so this is going to be for our clear zone cut. We'll also have a clear zone fill. We're going to set our feature definition. And here we'll just set this to slopes. We're going to have the terrain still going to be the active terrain. I'll just leave the point name the same, but we would want to come in. This is going to be a hinge point or that slope. So we want to change that back in, or our do not construct point in there. So from our dynamic settings, I'm going to go back to XY. We're going to go 0, 0, and enter. On our next point, we're going to clear off all these. So we want to clear off the end condition, our place, and the check for intercept. This point name, since we don't have one in the list for our do not construct, I'm going to see what this TP template point will give me for the feature definition. So if I scroll in the list, I'm going to find TP, and I want that to be template null point. So I don't want it to draw. This is going to be my template point, and then I'm just going to do an underscore, and this will be our DNC, so do not construct. And on this, I'm going to toggle on my do not construct. So this is going to draw my end condition, but I won't see this end condition as a component when I would draw. So I'm going to use this as a search criteria to see 18 feet out from our hinge point or that slope, but I'm not going to construct this element. All right, so that's the only difference on this TP, this do not construct, is I'm using this to control it to be 18 feet away, building in that criteria, and then I'm going to build a fill slope and my cut slope. So I'm going to set my precision inputs. I'm going to go to HS. I'm going to set this to be 18, 0. So as we know, the criteria for this was going to be 18 feet away, could be 20 foot away, could be 22 feet away. Right? So I'm going to do an R, and there we'll see that it's not drawing those components in there. Right? It's not, because it's set to do not construct. So that point is telling it, since we have this toggled on, we're using that end condition to search for the terrain model being 18 feet out, and then we're going to define it to be either 3 feet above this point or 3 feet below the point here. All right, and then this is where I always get confused in my, so we have that one. So from this point, we want to check for intercept, and we're going to place a point at intercept. We're going to clear our do not construct, and we're going to clear end conditions infinite. So we're either going to have, we're going to, from that 18 feet and from this point, so from the TP DNC, that's creating 18 feet from this point. But now we want to go 3 feet above this point. And since we toggled off that do not construct, when we place this next point, it's going to draw an end condition. From here to here, we're building in that's the criteria to be 18 feet out, but to be 3 feet above to give us a variable slope. So we're going to change this to our DL. And then from the last point that we put is the TP, the DNC. We want this to be 0 in distance, but we're going to go 3 feet above. And then I'm going to hit enter, and it's going to draw that point in there. And then I'm going to go ahead and finish that. So what that's doing is we're building in a do not construct to be 18 feet out, and then we're going to define it to be 3 feet above that point. So that's going to give us our variable slope. That's going to be 3 feet above our existing ground. So if we test this, and if I draw, there's our slope criteria that we're putting into up to 3 feet if we get above it. But it's going to go and draw that's this slope from 0. So that can be a variable slope as it hits 18. And we're going to have a variable slope up. We'll also have that variable slope down that we're going to build in there. Right? So that is on this TPDNC. I'm going to come in here. And this point name is going to be, maybe that is our cut. Or that is a clear zone. And we want that set. So even up here, I can do clear zone, and that will set my feature definition as well. So that'll be our clear zone, and maybe that'll be our cut point. Right. So we have our cop condition. We're going to do the same thing on for our fill. So we're going to come back here, go right click, we're going to add new component. We'll add end condition. This is going to be our clear zone, and this will be our fill. So we're still going to use slope. Terrain model, we'll set this to a priority of 3. So just so we don't have the same, priority coming off the path or that tree. And then on this one, we're not going to worry about the names right now because we're going to select onto our hinge point or the back slope. So it's going to merge it to this point. So we're going to, if we click on that, we're going to merge it to this point. Right, and then we're going to clear and we're going to clear and clear. We're going to set our do not construct. So basically we're going to do the same thing, but we're going to select on that point since this is already defined, and it's not going to construct that. So it's drawing it, and then we're going to set this to check for intercept, place point intercept, take this off. We're going to do DL. This is going to be our 0, -3, but we're going to set our clear zone point name, and we'll do underscore. This will be our fill. And this is going to be 0, and -3. And I'm going to hit enter on that, and it's going to draw that point, and it's still doing the do not construct, but our last point, since we took it off, we're defining a distance from this do not construct point. And then we're going to click finish on that. So if we hit fit view here, right? Our criteria to find the existing ground of this template point do not construct is going to be 18 feet. And then from this point to give our variable clear zone, cut, or fill, we're defining these to be 3 feet above this point and 3 feet below. So it's going to come and find the existing ground at 18 feet out. And then we can do a variable slope, whether it's above or below that existing ground. So now if we test this, there's our two slopes. If we draw our active terrain, that'll give us our criteria below it up to 3 feet or above and draw in there. So there we can have a variable slope that we can set to 18 feet or add a label into that if we need to control that a little bit more, right? So we have our default that is going to put it in there, but then we can come in and build off of this point. So if we wanted that horizontal, maybe this is a parametric constraint, or this label, this is our right-of-way seek that we put in there. And we can use that. It might not always be 18. Maybe it's going to go from 18 to 20. Or if we want that to set 20 feet, above, this is going to allow us to override what this value is. So I can apply that. And then if we want to come here, we can set, well, maybe we want, instead of 3 feet, we want that to be 5 feet above. Or this one is going to be 5 feet below or 3 feet below. So we can adjust those variables, but this allows us to build that criteria into it. And we can see how these do not construct elements are in it. So if we turn this, toggle that off and apply, right? On this point, it still has the others, but now we didn't have that. So it's going to come out here and find those. If this is toggled on, or do not construct, it's going to draw those other end conditions in there. So we're using multiple end conditions as do not construct, but then find that criteria and give us that variable slope that we have in there. Huh? So if we test this, all right, now we draw that active. It's still going to go 18 feet out, but we're going to go 3 feet below or 5 feet above. And if we look on this, right, we're not going to do end conditions infinite here because we only want it, the 18 feet is controlling that. So we either want it to be a certain height above or variable height in there. Right. So another restriction that we have here, let's see. And I think this is the last one. So another example that we have that we can build and test is we may have right-of-way restrictions, right, or comment on different projects. And in this example, we're going to have to draw in a wall to tie into, or maybe we have a certain slope that we want to tie into, right? We're still going to just get the process of building and having another target in our end conditions, or build an end condition that's going to search for a certain feature definition, say right away. And then if it finds that right away, we want to draw a wall, or we want it to draw, another solution or a different solution off of that tree. So we're just going to do a pretty simple wall, but we're going to use our end condition to draw that up. So this is going to be our solution, and we're going to use different techniques to target a horizontal feature, but also target our existing ground. And then we're going to create a parent-child relationship when we want things to display or not display. So if you guys don't have the ITL file that you got from Brian, what we're going to do is within the completed templates, and I can't remember if I sent this before or after I did the end conditions, but you have probably completed templates. Within that folder, we're going to have a wall template that we're going to drag and drop into. So this is just a wall template that we're going to build or place. This is already made for us. I changed it over to your feature definitions. But what we're going to do is we're going to build an end condition, and it's going to be a 50% slope from our hinge point or our slope. So from the start, and we're going to go 50% up. And then if it finds right away within that 50%, the feature definition, we want it to draw this wall. So we're going to add this wall perch to it. So we have a wall shape here. If not, I'll get this ITL to you. We also have the examples in the zip file that I sent to you guys as well. So you have that information in there. Right. So this is the end of what we're going to do. Right. So this is the cut wall. So example, this is our finished product. And if we look at this from our hinge point or our slope, we want it to follow our wall perch. And that's going to come out and search for check for intercept, place point, intercept, and condition. That we're trying to find that component out to be 50% a slope and 5 feet away. So if it finds this, we need to draw that wall perch. We need to draw our wall. Right? So we have one end condition here. We also have another end condition there. So we're linking end conditions together in this. But our first end condition, this is going to be a target type of a horizontal feature. So we're going to build that into this target here. Right? Then if this criteria is met, if we find that horizontal feature of wall existing, it's going to start drawing out that wall. So we have two different criterias. If we test this, we have our active terrain model, but we also have our feature. So if we draw our feature, right? So if this little target or that triangle is mimicking us finding our right-of-way line or our wall perch or the wall line, whatever feature definition that we pick horizontally, this is going to mimic that. So if we find that feature, a wall feature, and then if our other criteria, if it finds existing ground, that search criteria is going to go up to, and it finds that, and then we can have a variable height wall put in, because we're going to search for out to that point, finding the feature definition, and then up from that point, that's going to define the height of our wall. So that's what we're going to build in and get that solution in there. So there we have two targets that it's targeting, right? And we're going to build that to see how it is. But this is a logic behind it. So let's actually go and build that one. So we're in our wall. So that's our clear zone. There's that one. So I'm going to come up and we're going to create a new template. Right. And this is where we can search our multiple targets. So this is going to be our, we'll just say, for this purpose, we'll do demo. And this will be our cut wall. All right, and then I'm going to double click on my demo for cut wall. And we're going to add in our, go to here, we'll just call this our TP. So we're going to use our TP point. We're going to set that X0 or XY. We're going to right click, add new component. We're going to add an end condition. And we'll say that this is going to be our clear zone. And we'll say this is our cut wall. So we're going to have a search, or the component name is going to be our clear zone, our cut wall, our mesh. We're going to come in here that we want this to draw on. I don't want walls, slopes. We'll just pick slopes for now. So we're just going to have that be put on slopes, or maybe this is our stabilization, right? I don't know which one's here, or maybe we want to draw a sidewalk or a concrete. So we'll just pick slopes for now. But then the target type on this one, instead of terrain model, we want this to be a feature definition horizontal. And then we're going to define what we want this target type feature definition that we want to be. So we can pick here, we can go to maybe it's an existing feature. We have barrier walls. We want to define a retaining wall or a wall existing. Or if we have our new features, we can go to roadway, the plans, and maybe we have a wall or a different criteria that we want in there. But what this is going to do is, if we have this existing features or even other wall existing, we're going to use this as our target. And then this is going to probably priority at once. So we're going to build our first end condition or end component to search for a feature definition. All right, so now we're going to put this point in of TP, X, Y. This is going to be 0, 0. We'll put that in. We want to check for intercept. We're going to place point at intercept. Our end condition is infinite on the first part. We're not going to construct, so we don't want to toggle that on. We're going to do this at HS. And at this name, we'll just pick wall edge. So wall edge, or we can rename that to wall perch to kind of keep in with the point names. So we're going to rename that to wall perch. And this is going to be HS. So horizontal and a slope, we're going to go 5 feet away, comma, and 50%. Right, so we're going to go 50% up. I got to hit 50 in there. So that's going to be our first end condition that we put in there. And then from here, we're going to right click and finish that end condition. So now, instead of doing an active terrain model or an active terrain, we just have this end condition searching for a feature definition. So that's one criteria that we're going to build in there. Right. So now if we test this guy, we have to draw that feature definition. So this is the only criteria in there. So now what this is doing is if it finds by our cursor that feature definition, and we set that to infinite, it's always going to search for that feature definition. Right. And if it finds it by our crosshair, you go outside of it. So now we want it to find that feature definition. From here, we're going to build another end condition from that point. That's going to search for the terrain and go up to give us our wall height. So we want it to find that feature definition and then search up to find our terrain model. So this is finding our feature. Right, so there's our first part. So now we're going to put another end condition. So we're going to add a new component. We're going to add end condition. This is going to be our clear zone cut wall. And maybe this is our face. But this time it's going to be our terrain model and active terrain. Set that to priority 1. This could be our cross section, the slopes. Or maybe here we have a wall barrier that we want to draw, right? Because we're going to put that wall template on top of this. Right? We're not going to worry about the names because we're going to come in here. We want to go to the wall perch point because we want this end condition to stop or start here. So it's going to be built off of the wall perch to search for that. So we're going to highlight over there for our first point. And then instead of wall perch, this is going to be our, I think we want this to be our wall top. We don't have that. Oh, we do. We can set that to our wall top. Right, and then we want check for intercept, place point intercept, and condition is infinite. So we're going to toggle those on. And then this is going to be our DL, and we're going to set this at 0. And since we're going in a vertical face, we're going to go 0.01, so 0.01. comma, and we want to go 5 feet above. We could just go 0, but we're going to set this a little bit. So this point, we want it to be a little bit off from this wall perch, and that's going to be our DL point. And we're going to put this 5 feet above from the point that we last placed. And then we'll right click and finish that. So now we have our feature definition searching for the wall perch. And then from that wall perch, we have an end component or end condition for the wall top to search for our existing terrain or active terrain. So now if we test this, this is going to work together. So if we just did our active terrain, right, we're not going to find it because we linked this end condition off of our feature definition. We have to find that first. So if we find our terrain, so there we drew in our terrain, maybe that's at that height. But now we have the feature definition point finding. So anywhere that it finds that existing, maybe it's here up to that 50%, that feature definition can vary. And it's going to search for both of those criteria. So both of those criteria have to be met in order for this particular these end conditions to solve for, because we linked one to the other. We just can't solve for the feature definition here or the terrain. Right? So that's building the logic up in here. Now we're going to take our wall. I'm going to go into my folder here. I'm going to do a single click on my wall, and we're going to drag this to our wall perch point, and then we'll take our other points to control the height of it. So I'm going to do the wall shape. That's in my completed templates folder, and that might be renamed to end conditions. It might just be completed templates. I'm going to drag and drop that and place that on top of my wall perch. Those are going to merge those 2 points. And then I'm going to take this wall top and I'm going to move that down to this wall top. I'm going to double click on this point and we'll see that that is from my wall perch point. But then I'm going to add my vertical constraint to my wall point and I'm going to set that to 0. And that's going to move it down. So now I have both those points on top of each other. Right, so now that I've added my wall, I can go back and test. So my wall is always going to draw. So I don't want that. So I want my wall is going to be, this is a relationship. So I need to build in a display for this wall, the criteria in that. So the wall is always going to be there, which I don't want. I only want it if it's going to find that feature definition or my terrain. So if I find the feature definition, it's going to draw that because I'm out to the point, the wall perch point is controlling that. But then if I draw my terrain model, that's going to control the size of it. So I want to control when this is displayed or not displayed. All right, so it's always going to display, so I can create a rule or a relationship to have this displayed if only that end condition is being met. All right, so I'm going to double click on my wall shape and bring up, this is just my normal component. But I can kind of build a display rule by just adding a component. So if that end condition solves the wall display, the wall will only display if that condition is met. So that's a component. So I can add a regular component to my clear zone cut wall face. So if that finds the existing ground, then it's going to start drawing my wall component. So it's building kind of a display rule into that by just adding a parent component to display the wall only if that end condition criteria or the target is met. So if I click apply and close, and if I come back and test, right? So now we'll see that my main wall component is not displayed. It's going to be based on my feature definitions. So there maybe our wall existing is out to this point. And then if I draw my terrain, right? So our wall is going to draw, but then now it's going to start drawing the wall up to the existing ground to that certain height. So I'm building in kind of a display rule or a component relationship that if that wall component is only going to draw if the existing terrain is, that end condition is met. So the different conditions that we're building into this are met. So that is kind of the crash course on end conditions. Any questions from you guys that we went over, or anything in general? There's one more exercise in there, but I think I want to have you guys do that on your own, or we can run through that. It's really just kind of building on everything that we've shown here. But But is there any specific questions on end conditions that you guys have? I know it's a lot of information being thrown at you. It is recorded, so you always have that to go back to.
I don't have anything right now.
Okay. Is there anything on projects? So we can look at those now, or our follow-up if you guys have, if you think of something in between now or then, if you think of something over the weekend, hopefully you don't wake up in the middle of the night thinking about end conditions like I do, but maybe different solutions to that. If you do have questions or think of something between now and then, even next week, so that follow-up session that we'll have on Thursday is just kind of an open forum for you guys to come in and ask questions, get clarification if you need something. If there's something that you want me to look up or research on, you're welcome to send that to me. If there's a particular project question that you guys have, happy to help that. If I can't, I can research a little bit and get you some more information on there, or get that information to you or look at that. So that's kind of what these are. R2 is not necessarily just training. The coaching, it's coaching on your projects if you have project specific questions as well, either now or then. But if you guys don't have questions, I think that's all I had for you. We could turn it over and let you guys get back to your normal day and enjoy the time.
That was great, Todd. Yeah, that's a great place to stop. That's a great idea. Give them one more last exercise to work on their own, and put together any kind of project-specific stuff for next Thursdays. We're going to send a link out for that one to everybody that was on the call here, but also feel free to ask around your office. If there was somebody that wasn't on the call, try to get them on to the follow-up as well. But it's Todd's a great resource to have. My friend, we appreciate your time and efforts. Sure. And everything that you did right here.
Anytime.
Yeah. But this is a great place to kind of kill it and move on from there.
Yeah. Well, I think the next one too, Brian, is super elevation.
Yes.
If we can, I don't know if it's going to be the same group or if there are super elevation questions that you guys have. If we can have maybe some of those ahead of time, I can, kind of build a format or kind of review some of that. Hopefully this is working for you guys as well. Just kind of run through a PowerPoint and then exercises or examples that kind of make sense. Or if it doesn't make sense, let me know if there's something that we need to change in what we're doing as well. That would be more beneficial to you guys, because this is really for you guys getting that information on there too, and kind of keeping the questions coming and being interactive as well. So, but the next couple of them I think is super elevation, and then the last one that we have is ADA ramps, civil cells. So that I've got a couple examples from Michael of the standards. Those are really kind of hit or miss, or just that I think is just going to be a basics of building civil cells and geometry within there. But super elevation, if you guys have questions, specific questions on that, I would appreciate those. Even if you ask around, like Brian said, ask around the office, bring those questions to us, bring that to them. We can look at them. It'll probably be the same format, just running through and looking at that information. But end conditions.
I made a note of that, Todd, and we'll make sure that we push out the super elevation questions and data from the districts before the session. Okay,
cool. That is all I have. I do appreciate you guys on the time. I know it is a lot of information thrown at you, but always here to help with the CADD office. You guys are, I am the alum. You guys are always in my heart too, thinking about you guys and helping you guys out. So
good deal, my friend. All right. Well, we thank you again for your time and expertise and efforts in all of this. And hey, go get some lunch.
All
Be
right.
well.
Thank
All right.
you.
Thanks, guys.
Greatly
Thank you.
appreciated, Todd.
Yep. Thanks, guys. Anytime.